Hello everyone, in today's video we'll be going over the LockTalk, which is a medium web challenge from Hack the Box. I already started the instance and downloaded the source code, so let's get started. So LockTalk is API driven application with ability to send 3 HTTP GET requests to 3 different endpoints, which is a GET ticket, chat with specifying the JWT token and the chat ID, and then finally flag, which is our end goal in order to solve the challenge. So the first one is actually going to generate a JWT token for us. Then we are actually going to use this JWT token to supply and see the chat history, chat ranging from 1 to 10. And then finally, to retrieve the flag, we are actually also going to need a JWT token. So let's get started with analyzing the code and see what this application is doing anyways. So this is the Python application built on top of the Flask. We see that application, first of all, we have the config.py around the py, so pretty simple around the py, just starting the application, creating the application, while config is setting the fake flag for testing, debug is false, and then JWT secret key is actually being generated using the JWT key generate function. Now, it's not being disclosed, so we are not able to manipulate the token that easily to forge the token as we want because we don't know the secret, but it may be the weak secret, we never know, so it's worth trying in our testing later. Then, if we want to expand the app, we see API, and then there is a different JSON object. This is, I believe, for a chat, so there is different chats that we are able to retrieve based on the chat ID, so we are not interested in this specific JSON data at the moment. Then we have the routes and init.py, which is just starting the application using the blueprints. So when it comes to the routes, this is something that we are interested in because those are all the API routes. So there is a get ticket, there is a chat ID, and there is a finally flag. So for getting the ticket, we are being allowed to get a ticket. Actually, we are getting the ticket as a guest. Yes, our role is actually going to be set as a guest, and the user is going to be a guest user. And the ticket is actually going to be generated by us, and the ticket is actually going to be JWT token, as we can see here in this part of the code. Finally, or actually later on, we are actually able to use that JWT token with specific chat ID to retrieve the chats. So maybe there is some just information hidden in the chat. We're gonna go ahead and take a look at that as well later. And then finally, if we have JWT token with the role set to administrator, we are actually able to access the flag endpoint and retrieve the flag. But we know as we already know, once when the JWT token is generated for us, using the get ticket endpoint, role is being set to guest. So my initial idea is that we have to forge and manipulate the JWT token, change our role to be administrator, and that way access this endpoint. So let's see how we can do that. But to obtain a JWT token, we have to send a GET request to this API endpoint. So if we try to execute it, we're going to see the response body saying that the request forbidden by administrative rules. And this is something really interesting because I didn't see this error message if we try to look at the backend. If we try to look at the backend of the application, there is no error message like that. So if we are struggling to find it right away, it shouldn't be a problem because it's a small app, but if you are struggling to find it, we can also always go ahead and utilize the search function or the VS Code. So we can go ahead and copy the error message, search for it, and then see where is it hiding. So it's part of the main.js, so which means that's happening on the front end rather than on the back end, because we know the back end is driven by the Python, which is really interesting. And we see indeed that we try to access API, we want get ticket with the type requested get. We are getting the forbidden because of the sun. So we see the 403 is getting the forbidden, and then we are actually getting the result. An error is actually the error that we are seeing right here. So something is preventing us to access this specific endpoint by just sending a HTTP GET request. So if we go back and look at the code, something that caught my eye is this configuration folder, and within the configuration folder we have something interesting, right? We have the haproxy.configuration file, but we also have requirements as well. So requirements at the moment, that's something that's really interesting for us because we have Flask, we have request library, UWSGY, and Python JWT. Might be interesting later, but at the moment we first have to bypass this check, which is actually going to allow us to obtain the JWT token so we can proceed further, because without the JWT token, there is not much we can do within this application. So by looking at the HA proxy, and if you're like me, I didn't know about HA proxy before this challenge. So HA proxy essentially just a free and open source software that provides a high availability load balancer. So it's some kind, you can think about it as a load balancer and a proxy as well, which is really handy, and many applications are using it. But the problem with HA proxy here in this one specifically, if we go back to the code, is that HA proxy here is actually preventing us. So why are we not able to access a API we want get ticket? Because it's saying here that HTTP request deny if our path begins, if our URL path begins with this one. And we know that we are not able to access the v1 get ticket any other way. We have our path, if we want to get the JWT token, is always going to start with API v1 get ticket. So quick Google search and a little more of research investigation about this one led me to this CVE, which is authentication bypass for HA proxy. And HA proxy before version 2.8.2 accepts the pound as a part of the URI component. So if we take a look at our burp and we see the proxy and we see the HTTP request history, we see the error message right here, and we see indeed that the HA proxy actually is configured, and it's actually going to prevent us to access this endpoint if our URL starts like this. So if we send this one to repeater and append the pound at the end, which is actually going to change this request, and we see from the description of the vulnerability is actually going to accept the pound as a this is actually going to alter their rule, and is actually going to allow us to bypass their rule that we see in the configuration file of HA proxy because of the vulnerable version. So if we send it this time, we are getting the JWT token. If we send it without it, we won't be able, and we're actually going to see this 403 forbidden error message. So let's go ahead and add a pound, obtain the JWT token. With this JWT token, we are able to go ahead and see the chat history and the chat data. So we are actually able to supply JWT token, and let's say enter chat with an ID of 1. So we are in the response body, we are getting the JSON object with multiple different key value pairs about the victims and the open bit party who is actually responsible for this ransom and encrypting all the customers or the victims data. So if we take a look at the history again in burp, we see that we are now utilizing the JWT token, and if we JSON Web Token is really handy extension, which is also not the JSON Web Token but the JWT editor, but we're going to take a look at it later. So JSON Web Token tab is actually going to be also really handy. We can send this one to the repeater. It's going to be easier to look at it. And then we see that the payload indeed says the role for guest and the user is guest user. If you remember, if you take a look back at the code, if you go to the routes, we see that once when the JWT token is generated for us, we are indeed getting the role to be a guest and the user is guest user. So everything is working as expected after our analysis of the code. So we won't be able to access anything. So for example, if we are able to access a chat, but if we want to access the flag, we won't be able to do so because guest user does not have the required authorization to access the resource. And application knows because our payload is saying that we are a guest user and our role is a guest, and in order to access this flag endpoint, we need to have the authorized roles administrator. And we see that current app config.get flag, we know that once when we are able to forge this JWT token, we'll be able to get a flag and solve the challenge. So now those configuration files comes back into play, especially this requirements.txt. So my initial thought would be, okay, this if I can somehow, if application is not checking the signature of the JWT token, I can go ahead and modify it right away. So there is a couple different JWT token attacks that I tried, such as using null algorithm. I was also trying to use a hashcat and John the Ripper to brute force the secret of this JWT token. Secret is strong, so I was not able to bypass this. Because if I was able to get a secret, I can go ahead and modify the token however I would like. So that's out of the play, as well as non-attack. So for example, we can go ahead and use non-algorithm and go ahead and send the attack. This is just algorithm is not allowed, none. Which application it does not allow this one, but this is just one attack factor when it comes to JWT token. So if we try to access flag again, pardon me, and if we try to modify the user, or actually the role, to be administrator, I can spell. We see the verification failed for all signature because application knows that we alter with the payload and the signature is actually cannot be verified for this one. So we are not able to modify the JWT token that easily and this way. So upon the further investigation of the code, I realized that the Python JWT is 3.3.3, which is another CVE for solving this challenge. And the problem with this one, I already loaded up, is an attacker who obtains a JWT token, which we did, can arbitrarily forge its content without knowing the secret key, which is great for us because we don't know the secret key. Depending on the application, this may, for example, enable the attacker to spoof the other's user identities, hijack their session, or bypass the authentication, which is great for us. And why is this happening? This is happening because of the combination between the Python JWT and dependency JW crypto. If we take a look back at the code, we're going to see that application is indeed using the JWT and also using JWT crypto. So what is the explanation of this one? So by mixing the compact and JSON representations, the attacker can trick JWT crypto of parsing different claims than those over which a signature is validated by JWT crypto, which essentially means that if we manage to go ahead and forward the JWT token to be in a JSON as a JSON object and supply it that way, we're going to be able to bypass the authentication. And this CVE is really dangerous. You can see here is marked as a critical severity, and it's really good for us because we at the moment we only have the JWT token, and that's the only thing we need. So I write down the quick Python script for it. So I use the JSON, I use the necessary JSON, JWT crypto, base64, etc., all the necessary imports I need to have, and then JWT is going to be a string, inject a claim key and inject a claim value, because if you remember we need the JSON object. I said the role has to be administrator because that only if the role is administrator we can access that endpoint flag. I split it out the header payload and the signature after the full stop, because every JWT token consists of the three parts being the header, payload, and signature. So now we are interested in with payload. If we take a look at the burp and the JSON Web Token tab is actually this one. So everything that's actually going to be described as a user. Header looks like this, and the signature is what application is using to validate our token. Then I decoded the parse payload is actually going to be base64 decode of the payload, and then I'm able to inject the claims which I specify here, and then finally construct a new token using the header, fake payload, and the signature. And I'm using a new payload to go ahead and supply this token as a JSON object. So now if you run this application, quick Python script. Oops, I forgot to specify the JWT, so let's go ahead and grab our JWT that we obtained earlier. It looks ugly, but it's going to work. So this is our, let me just move this one out of the way. So this is the JSON, this is actually JWT token just in a JSON form. So if we copy it out, put this back here, and then navigate back to the flag endpoint, we can go ahead and replace this one, authorization token, with this in JSON format. So now we can send the request and we obtain the flag. If we take a JSON Web Token, we see that the role is administrator and user is still guest user, but that doesn't really matter because application is only checking the role, which is really good for us because we see that our payload is working just fine. We were able to modify the role to be administrator, and then because we supplied a JSON, because of that incompatibility between the JSON, between the, I forgot the names of the libraries, if we take a look at GitHub page one more time, between a different claims between the Python JWT and the JW crypto. But this exploit is indeed critical because it allows us to bypass complete authentication, forge the cookies, and then we can access any sensitive point if we encounter this version of the Python JWT in the wild that we found in our requirements at txt. So thank you for watching. I hope you enjoyed, and see you in the next video.